This is Screencast 1 for Unit 1, Lesson 4, and I'm on page 48. The essential question for this lesson is, how do science and society work together? By the end of this lesson, you should be able to describe the impact that science has had on society and society has had on science, especially in regard to political, social, and economic concerns and decisions. Okay? Please make sure that you are answering the questions beginning on page 49 and that you continue all the way through answering the questions, including the lesson review. There will not be any vocabulary on this lesson. All right, I'm on page 50. What are some ways scientific research has impacted society? Scientific research builds knowledge using observation and experiments. Research often provides explanations that are very different from what was previously believed to be true. For example, throughout history, many people have believed that the Earth was flat. The idea that the Earth is a sphere can be traced back to the scientific observations beginning with ancient Greeks. As another example, the pictures below trace how scientific knowledge about disease has changed over time. Our understanding about the world around us expands as researchers build on scientific knowledge to ask and answer new questions. Okay, if you look at the first image, it says, from the Middle Ages until the 1800s, many people believed that miasmas, or poisonous vapors, caused disease. Then you go to the next one in 1677, using a simple microscope that he had built himself, Antoine von Leeuwenhoek observed that tiny organisms that he called animalcules. Later, his observations were used to support the idea that some diseases are caused by germs. Okay, looking at page 51, at the top, Edward Jenner hypothesized that vaccination with cowpox would provide immunity against the killer disease smallpox. In 1796, Jenner performed his first vaccination on a local boy. After being exposed to smallpox several days later, the boy was found to be immune. Okay, then the next one. After careful scientific testing of over 20 generations of mice, German doctor Robert Koch proved in 1876 that the disease anthrax was caused by a bacterium. Koch and his team later identified the specific bacterial causes of tuberculosis and cholera. Okay, so we go from believing in the Middle Ages that poisonous vapors in the air cause disease to more recently understanding that it is pathogens such as viruses and bacteria that cause disease. Okay, this is what my page 50 and 51 now looks like. I highlighted the sentence that said, research often provides explanations that are very different from what was previously believed to be true. That is a very important statement to understand. And also I went and just bubbled those blue summaries of some of the key things about how our understanding of disease has changed over time. So you might want to just read those and make a special note of them. All right, I'm now on page 52 and looking at the blue heading. It says, in what areas does science help us make decisions? Science has led to life-saving discoveries and has taught us to protect our resources too. Science also helps people make decisions that affect us all. For example, scientists can gather data about the health of our environment. Then decision makers use these data to make rules and laws. Water quality rules and laws depend on science. Over 150 years ago, Dr. John Snow found that bacteria in polluted water could make people sick with cholera, which is a deadly disease. The polluted water was not safe to drink. Now, decision makers use science to decide how much bacteria and other substances can be found in water before it is unsafe to drink. So that's just an example. On number 8, it says, as you read, complete the graphic organizer below about science and decisions. Basically, the little bubble that they put was science affects decisions made. And then all of the little red headings on page 52 and 53 go in the other bubbles. So science affects decisions made in local communities, at the state level, at the national level, and at the international level. I am now on page 54 and 55, where it says, how can science and politics affect each other? Scientific investigations have led to new technologies that have improved human lives. How do scientists decide what to investigate? The direction of science is influenced by many things, such as political, societal, and economic concerns. Science, in turn, affects politics, society, and the economy. The space race is an example of how science and politics affect each other. In 1957, the former Soviet Union sent the first satellite into orbit. American leaders wanted to show that we could excel in space exploration, too. So that would be an example of how politics drives what we do in science. Okay? All right, on page 54, please go back and highlight where it says the direction of science is influenced by many things, such as political, societal, and economic concerns. Science, in turn, affects politics, society, and the economy. Because over by number 11, it says, as you read, underline events that influenced the path of science. Okay? Basically, they're pointing out that those things are political interests, societal interests, and economic interests. I'm on page 56 now. How do science, society, and economics interact? Politics are not the only drivers of science. Societal needs and economic influences, societal needs and economics influence science too. If society sees no value in certain research, then scientists may not get the funding for that research. Also, people may not buy unneeded technologies if they are made. Okay? So we do pay attention to what society's needs are, and typically scientists that are trying to meet those needs are the ones that are going to receive funding on a more regular basis. All right, so under the first red subheading, which says society has a need, one example of societal needs driving science happens when there are outbreaks of disease such as polio, AIDS, or the H1N1 influenza. Polio, AIDS, and H1N1 are diseases caused by viruses. These diseases can cause suffering and even death. Society needs solutions when diseases threaten the health of the nation and the world. So society turns to science. So if society decides, gosh, we really need to fix this because people are dying of these diseases, then what they're going to do is people are going to say, we need to dump more funding into scientific research to come up with the way that we can handle these diseases, vaccines or whatever. Okay? Look at page 57. Science addresses the need. Scientists find many ways to meet the needs of society. Societal needs may lead some scientists to prioritize research such as vaccine development. Vaccines prevent people from getting viral diseases. After an outbreak of polio in the early 1950s, Jonas Salk pioneered the first successful polio vaccine. This vaccine was given as a shot. Later, Albert Sabin developed another polio vaccine that was taken by mouth. Scientists continue to explore and learn new things. Sometimes, new scientific knowledge improves upon or challenges existing knowledge. Okay. Third red subheading, science and economics affect each other. Preventing disease is just one example of how science benefits society, but science can be expensive. Priorities for how to spend money on science must be set. Science, in turn, affects the economy. Life-saving improvements allow people to live longer, which changes how much money we make over our lifetimes. Making more money allows us to spend more, and spending more puts money back in the economy. So all of these things are wrapped up together. They all affect each other. So science, society, and economics all affect one another. All right, as I said at the beginning of the screencast, there isn't any vocabulary for this particular lesson, but you do still need to go back through the lesson, answer all of the active reading questions that you run across. You also need to do the visual summary on page 58, and you need to complete the lesson review on page 59. All right.